Hello, Algebra 2. Welcome to the parent functions packet. It's a little bit cut down, that's okay. Here's some things that I want you guys to do. Make sure, number one, that you've got Desmos downloaded. So Desmos, either on your iPad or you can go to desmos.com. So number one, have Desmos ready, because that's what I'm going to be using. Have Desmos ready. Let's try this. Ready. So on the iPad, you want to download from the app locker, from the app locker, yeah, securely. App locker. And if you're on like on a PC or anything like that, on anything else, go to desmos.com. You don't have to make an account. You don't have to do anything like that. Have Desmos ready, anything like that. If you want to, I even have it on my phone because I'm nerdy like that. I use it sometimes. But anyway, so that is how we're going to start this one for Desmos. Have Desmos ready, and two, have some fun. It's easy for me to say that, I know, because I enjoy the math. But this right here, this is going to be an important part, setting up CFR3 and CFR4. So CFR3 is describing transformations of function graphs, and CFR4 is actually calculating or making the changes to the function graphs based on what you're given. So let's go ahead and take a look at what I want you guys to do. Second page. So you've got a few of these. We've got a bunch of different functions that we're going to be looking at. And basically what I want you guys to do is to sketch some graphs in here of what these functions are. So you're going to be filling in some tables of some critical points. I'm giving you some of the X values over here, and I want you to find the Y values. Don't worry about the odd and even and neither function type right now. So don't worry about this right now. I do want you to fill in the domain and range. So domain, range, I want you to fill in these critical points and do the end behavior. When it comes to additional notes, I will let you know what those are. Make sure we've graphed it also. And up top tells you what function we're going to be working with. In this case, it's the absolute value of X. So I'm going to be using the absolute value of X, and I've got some critical points. Well, let me show you how to do this really efficiently, how to get these critical points efficiently. So I'm going to go to Desmos. Let's see here, Desmos. And in here, I'm going to type in, if I just type in the absolute value, for me, it's down here. I'm not sure exactly where it's going to be for you. This is the absolute value of X. This is the absolute value of X. And this is the graph for it. It looks fantastic. Looks fantastic. Here's the thing though, we got some graphs, but we need to understand where the critical points are. So in order to do that, we're going to be, while we're in here, notice how my cursor is in 1, or in by the red absolute value. I'm going to hit the little settings, and I want to hit the little table button here. And now it gives me X values and absolute value of X. And what's really nice is I happen to have these critical points in there. Now that's not the case for every time. It's not the case every time, but it is for this time. All right, so I've got the critical values in here. So if you plug in -2, the absolute value of -2 is +2. It's a distance. Absolute value is a distance formula. It just says it doesn't matter where this is, I'm 2 units away. It could be 2 units negative or 2 units positive. All right, so you would fill these in to your critical points. You would draw the graph on there, and then you'd make your decision on end behavior and domain and range. So let's go ahead and do that. Let's go ahead and do that. So my critical points, we said, again here, and again, if you don't know how, you can either split screen if you're on a computer, or bring two different apps up if you're on the iPad. The absolute value of -2 was 2. Absolute value of -1 was 1. Absolute value of 0 was 0. We got 1 and 2, my critical points. I'm going to go in here and graph these, or plot these points. These are my 5 critical points that I'm going to do. And I can take these 5 points and I can transform them, and you'll see how that works later. And if I transform them, I can make them look however I need to using these 5 points. Let's go ahead and graph these. This is one of those interesting graphs. Notice how I'm going way out as far as I can. Get in the habit of doing that. Here we go. Okay, got these, and I've got the arrows at the end indicating that this function just keeps going. Okay, so again, don't worry about the odd and even function type for right now. The domain is all real numbers, because I've got this arrow pointing left and an arrow pointing right, which means my smallest x is negative infinity, my biggest is positive infinity. And my range, well, my lowest value is 0, and it can be 0. This is one of the very few functions also that comes to an actual point. Normally, we're going to see kind of some curves curves coming through there. This one actually comes in at a point like that. Okay. All right. So my range, and I'm going to use interval notation when necessary. This is one of those cases. I like interval notation because I think it's the most efficient. And my lowest value is 0. My biggest is positive infinity. And I need to put the little parenthesis there because it can never equal positive infinity, but it can equal 0. We even proved that right up here. All right. And behavior on the right-hand side, if I look on the right, the arrow is pointing up. If I look on the left, the arrow is pointing up. So they both have arrows. They're both pointing up. Therefore, my end behaviors are both positive infinity. All right. I want you guys to do the same thing for the rest of the graphs in here. I'll also post my solutions on what these look like, but this is what I want you guys to work on. Take care. Have a great day.